We're on 2-5s, textbook homework, and we are starting on number 2. So we are testing to see if expressions are equivalent. So on number 2, it says you can use a table, a graph, or you can simplify the expression. So when I look at these two, I'm going to choose to simplify. I think that's the easiest way to do this, mainly because when I see 4n minus 15, that one's already simplified. There's nothing I can do. I can't combine these. They're not like terms. So that means all I have to do is simplify the other one and see if it matches. So I have 4 times n minus 4 minus 1. So I can simplify that. If it matches 4n minus 15, they're equivalent. If it doesn't, then they're not. And then I don't have to make a table or a graph. So I'm going to go ahead and distribute. I'm going to leave the minus 1 alone. So I get 4n, and I'm going to get minus 16. And when you look at this and you're saying, okay, I'm trying to get to a 15, I got a 16 and I got a 1, but you got to be careful. This is negative 16 minus 1, and that's minus 17. And so these are not equivalent. A little tricky at first. It almost looks like they are. So we got to be careful there. Okay, number 3. We got 3x squared plus 6x times x plus 2. That's got some simplifying we need to do. And we have 3x squared plus 6x squared plus 2. Also has some simplifying. These two are like terms. They have the same variable with the matching power. So those can be combined. I'm going to automatically do that right now. That's 9x squared plus 2. Over here, I'm going to distribute. So I'm going to leave my 3x squared alone. 6x times x is 6x squared. 6x times 2 is 12x. These are like terms. 12x is not. It does not have the same power. So these two are going to go together. We're going to get 9x squared, and we're still going to have 12x. These are not equivalent, and that's my answer there. So instead of plugging in a bunch of numbers and trying to run it through these, which would work, it would show that they're not equivalent, but that's going to take you way more time. If you've got this skill in your toolbox, it can certainly save you a lot of time. Okay, number 4. Now, this one, I know how to expand this, but you haven't learned that skill yet. So when you look at this one, you might want to do something different. And I'm going to go ahead and make a table because I don't believe most of you know how to expand this. Because remember, this means square times itself. So you would be multiplying 5 plus x times 5 plus x. And if you don't know how to do that, then you're not going to be able to simplify this. So let's make a quick table. And I'm going to choose x values of 0 first. So 0 plus 5, that's 5, and 5 squared is 25. What if I put 0 over here? 0, 0, 25. Okay, that's good so far. Let's put in something easy like 1. 5 plus 1 is 6. 6 squared is 36. Put in a 1 over here. You're going to get 10 here. 1 squared is 1. 25 plus 10 plus 1 is 36. So right now they appear to be equivalent. I'm going to put a negative number in there. Let's go negative 5. Negative 5 plus 5 is 0, and 0 squared is 0. I put in negative 5 here. I'm going to get negative 5 times 10 is negative 50. Negative 5 squared, that's a negative times a negative. Negative 5 times negative 5 is positive 25. If I add all this up, I'm also going to get 0. So using a table, I've used 0, 1, a negative. I'm going to say yes, they're equivalent. And I'll quick show you how you would simplify this. Just a quick sneak peek. We'll work on this kind of stuff later. But it's distributing, but both of these have to get distributed. So the 5 gets times by both. So 5 times 5 is 25. 5 times x is 5x. And then the x also gets distributed. So you're going to get 2 more terms. So x times 5 is another 5x. This x times x is an x squared. And then you would combine like terms. These two go together to make 10x. And you can see that this matches this. So if you have this skill, it's kind of like double distributing, then you could use simplifying to prove it, but a table also works. Okay, number 5, we have 3x squared. Is it equivalent to 3x in parentheses squared? So again, let's say you don't know how to simplify this. You could plug in some numbers. So let's try 4. So if we plug in 4, for this one, 4 goes in. You have to square it first before you multiply. So 4 squared is 16. And then you got to do 16 times 3, which is 48. If you did that here, because of the parentheses, order of operations says I multiply first, then I do the exponent. Over here, there's no parentheses, so exponents comes before multiplication. Parentheses before exponents. So it's 3 times 4, that's the number I'm plugging in, 12. And 12 squared is 144. So these are not equivalent. And I just provided a counterexample. Okay, 4. You plug in 4, and it doesn't work. That's a counterexample, a number that makes this untrue. Perfect. Let's say you wanted to expand this, though. Let's say you wanted to simplify this. Anything squared means times itself. This is 3x times 3x. That's what it is. Well, we know what that is. 3 times 3 is 9, and x times x is x squared. So really, you have 3x squared and 9x squared. So clearly, they're not equivalent. Okay, number 6. Consider these expressions. We're going to make a quick chart. And I'm going to squeeze it all in here. So I'm going all the way from -3 to +3. So letter A, we're going to copy and complete this. So let's go ahead and fill this in. Start with 0. 0 times 0 is 0. 2 times 0 is 0. 1 times 1 is 1. 2 times 1 is 2. 2 times 2 is 4, and 2 times 2 is 4. 3 times 3 is 9, and 2 times 3 is 6. So clearly you can see these are not equivalent, right? We're getting different answers. We got the same answer here and here, but these did not. How about -1? Excuse me. -1 times -1 is 1. 2 times -1 is -2. -2 times -2, that's +4. And -2 times +2 is -4. -3 times -3 is +9. 2 times -3 is -6. So there's part A. Part B. We're doing A, B, and C on number 6. Give 2 values of x for which they are equal to. So 0, they come out equal, and 2. And part C, give 2 values of x for which they are not equal. So any of the other ones. So -3, -2, -1, 1, 3, any of those. All different answers there. All right, that's number 6. So we're going 7, 8, and then 10 through 15. All right, number 7. Perimeter, first of all, of a shape means the distance around the outside. And so if you had the actual numbers, you would just add them up, all the numbers of the sides, the distances around. So if they are expressions and we're trying to find the perimeter, we're adding them all up. So it says the perimeter of the square can be written like this, which is all of them added up. Or instead of adding, since they're all the same, you can just multiply one of the sides by 4. We're going to verify that these are equivalent. Okay, so we're just proving that this is actually true. So our first one is 2x plus 3 added up 4 times. 2x plus 3, 2x plus 3, and 2x plus 3. And the other way to do this is to just multiply one of those sides by 4. So 4 times 2x plus 3. We're going to prove that these are equivalent. So first, let's just simplify this one. That's 8x plus 12. And right here, 2x, 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 2, 4, 6, 8x, 3, 3, 3, 3, 3, 6, 9, 12. Okay, and we've proven that they are equivalent by simplifying. Number 8. Another shape, still talking about perimeter, so that's adding up all the sides just like we did here. We're going to write two equivalent expressions for the perimeter. So one of them would be to add up all the sides. So 3x minus 2 plus 3x minus 2. And we need 5 of these. There's 3, here's 4, and here's 5. So there's one long expression that represents the perimeter. But the other thing that you could do is just multiply, since all the sides are the same, by how many you have. And you have 5 of them, so it's 5 times 3x minus 2. Good to go. And if you simplified this, you get the same as if you simplified this. They don't ask you to do that, so we're not going to bother. Okay, number 10. Some quick review now, just practice on some simplifying, including some negatives from 2-4. So number 10, when we have that subtraction sign in front of the number that gets distributed, we need to consider that a negative. So this is a negative 5 when it gets distributed. The 8b is not involved, so bring it down. So this is a negative times a positive, which will be a negative, so I put the minus. I don't automatically bring this down. If I had a negative in here, it'd be a negative times a negative. It'd be positive, and I'd put a plus. So you cannot just drop this down. Okay, so I distribute. That is negative 35b, and then I distribute here. Negative and a positive is a negative, so I put minus 15. Now I'm just combining like terms. So I'm going to put these together. This is a positive 8, and this is a negative 35. The minus 15 is going to stay separate. It's not a like term. It does not have the similar variable. So putting these together, positive 8 minus 35, or positive 8 plus negative 35. That's negative 27b. Okay, number 11. Looks a little complicated because we have decimals, but we'll just use our calculator to handle it. No big deal at all. So we're going to do negative 1.4 times 2. So we're going to get negative 2.8v. Negative times a negative will be a positive. So it's 1.4 times 4, 5.6. And then we still have 3.6v. So I need to combine like terms. The 5.6 does not have a variable, so it cannot combine with any of this other stuff. It's going to stay a plus 5.6. And then a negative 2.8 plus 3.6 is just 0.8 positive 0.8, so 0.8v. Number 12. So we've got these two fractions. And we talked about this property. If you have the similar denominator, we were going the opposite way most of the time, where we had a whole bunch of stuff on top of just one single denominator, and we split it into 2, but we can also go the other direction. So we can put all of this just over 3. So we have 12m plus 2 minus, now we're minusing this whole quantity. We're not just minusing the 6. So that actually means we're going to need to put this into parentheses like this. We are taking this whole thing. If you want to put this in parentheses too, you can. This whole thing subtracted by this whole thing. So parentheses will represent that. Now, why does that make a big difference? Because this negative is going to get distributed. Both of these terms have to be subtracted. If you don't put parentheses and you just attach this to the 6 and you leave this a minus 1, you haven't subtracted the negative 1. You've only subtracted the 6. So we need the parentheses, and we need to distribute it as a negative. So I'm going to rewrite this now. I'm going to leave 12m plus 2. I'm going to distribute the negative, so minus 6m. And then a negative times a negative makes this a plus 1. And that's the big part. I still have 3 on the bottom. I'm going to finish simplifying this before I worry about that. So I have 12m and a minus 6m. So 12 minus 6, that's positive 6m. And I have a 2 plus a 1. And that's 3. All of this is over 3. And this is not done. I can simplify this further. Because I see 6 and 3 both divide nicely by 3, I can split this up into 2 pieces. 6m over 3 and 3 over 3. And now I can simplify those. 6 divided by 3 is 2, so that's a 2m. And 3 divided by 3 is 1, and so it's a plus 1. Now it's fully simplified. Okay, 13. We're going to determine if all of these are equivalent to the given expression. So starting right here, first thing I need to do is simplify this. So let's distribute. We're going to get a negative 18, and we're going to get a positive 5x. So as we go check A, B, and C, and D, they have to have a negative 18 and a positive 5. So if I look at letter A, I have a negative 18, and I also have a positive 5, because two negatives will make a positive. Minus a negative is a positive. So that matches. This is a yes. Letter B, distributing. I'm going to get a negative 18, right? Negative 18. So that looks good. But then when I do this times this, I will get a positive, but 9 times 5 is not going to give me a 5x. So this is no. Letter C, negative 18, negative 5. That's no good. That's a no. And then this obviously is the exact match. So this is a yes. Okay, so that's 13. We got 14 and 15. 14 is one of these number puzzles. So part A, we're just going to pick any number we want and run it through this. And this, you can see if you look ahead, this is that 7 is having one. So we've done this one before. Let's see. I'm going to pick, let's be goofy and pick 0. So add 23 to your number, that's 23. Double the sum, that means double this number. So that's 46. Subtract twice your original number. Well, twice of 0 is just 0. And so I'm still going to have 46. We're going to add 3, and that's 49. I'm going to subtract 42 as my last step, and I get 7, and that's what you should be left with. So I use 0, which can be a little confusing here. When you say subtract twice your original number, well, it's 0. So what's twice 0? Still 0. So don't confuse yourself. You can pick any number you want. You're going to get 7. Now, part B is the more important part. Let n be your original number, and let's run it through this. So first we're going to add 23. That's n plus 23. Then we're going to double your sum. So we're doubling this. That means timesing by 2. So we're doubling this. Now you could just go through and double this and double this. That's what we're doing by distributing it 2. So we get 2n, 46. Then we're going to subtract twice your original. Well, the original was n. Twice the original is 2n. So we're going to minus 2n. Subtract twice your original number, minus 2n. So 2n minus 2n, they go away. We're left with just 46. There's no more n's. We're going to add 3, and that's 49. And we're going to subtract 42, and we get 7. And last one, 15. Letter A, when you multiply variables, the exponents get added. So p times p is p squared, and then times another p is p to the third power. We want to see the difference between that and adding. That's the whole point of this question. When we add them, we just add the coefficients. Nothing happens to the exponents. So this is a 1p plus a 1p plus a 1p. That's a 3p. Letter C, when you're multiplying, the coefficients do get multiplied. That's 2 times 2 times 2. So 2 times 2 is 4, and 4 times 2 is 8. But when we're also dealing with the exponents on the variable, just like we had p times p times p, that's what we have here too. So you're adding up those exponents. It's a 1, a 1, a 1. And so this is p to the third power. But what about letter D? Now we're adding them all up. You just add the coefficients. Nothing happens to the exponents. So it's 2 plus 2 plus 2. This is a 6.